Hello and welcome back to our channel Physics Safari. My name is Abhishek and today I'm going to discuss with you some more questions and good examples for the vertical motion. So far I have discussed about your displacement, distance, velocity, accelerations, and I have done few questions on that. Now today also I've told you about the vertical motion, and today I'm going to discuss some good examples on the vertical motion. Now going further, once I'm done with this, I'm going to talk about the variable acceleration questions, and then I'm going to do some questions from the Eurodov and the previous year JEE questions, and I would also include some questions from the NEET previous year of the topic kinematics. All good? So chalo, let's have a quick recap of what we have done so far. So here's my marker. Okay, I get it. Okay, now when we talk about the motion in vertical in particular, we had seen that when the body is thrown upward with the velocity u, then height is how much? U square upon 2g, and the time period of it goes up and comes back, that is 2u upon g. The time that will take to reach only to the top, that would be given as just u upon g, and also since it is a motion in one dimension, you take either the top upward as positive and the downward as negative, or also in certain questions based on the demand or the need of the question, we can choose to have the downward direction as the negative positive and the upward as negative. Well, that's completely upon you. That is completely dependent upon the requirement of the question. Okay, now going further, let's say if I have let's have an example. Let's suppose this time I'm going to take that a body is thrown from a cliff from certain height. It's already at certain height, and from here it is now being thrown up. So let's suppose the object is thrown up with a velocity, maybe you can say something, maybe 20 meters per second. The object is thrown 20 meters per second, and let's say the height of this cliff is probably 60 meters. Now you have to tell me how much time would it take to go up and come back to the ground. Time taken to come back to the ground. That's how we have to do. Okay, so let me decrease a bit of sound from here and the light. That's unnecessary, consuming the battery of the laptop. Okay, now here we have. So let's suppose if it is thrown up with a velocity of 20 meters per second and it has to come back to the ground, how much time would it take? The idea is very simple. You will first figure out that the path taken by this object has to be somewhat like this. Of course, it has to be straight, just to make sure that to understand, we take this path, or else it's going to go up and come back to the same. Now, the point is, how much time would it take to reach to the earth? Look, there are several ways of doing it. Two prominent ways which I find is kind of good and easy to do. I'm going to discuss that with you. The first thing, you can actually look at this entire motion in two parts. The part one would be somewhat like, the time that will take to go up its motion till the point, let's suppose this top point, let's suppose that is A. And the second part of the motion, I would say the time or everything that it takes to come from here to the ground. So these are the two parts in which I can break down this motion. Okay, now let's say while going up, it takes some time t1. Well, this is not going to be valid over here. This will not be valid. The reason being, it is not coming back to the same level. It's going to a different level altogether. So the process, the formula, this 2u upon g will not be valid over here. So karte hain. First of all, let's understand the time it will take to reach to the top. The time, let's suppose t1, that would be how much? U upon g. Right away from the formula you can see. Now, what is u? U is 20, g let's say take 10. So this is going to take how much time? 2 seconds to reach to the top. Okay. Now, the good point is when it comes back from the top, initially it should be having initial velocity how much? 0. So in kinematics, you always try to frame the equation with some initial velocity as 0. Your life is going to be simple, my dear. Try to include the initial velocity with the 0 and then try to frame the equation. That would always going to help you, So always look for an opportunity if you could just put the value of u as 0 or not. All good? Great. Now let us figure out the time that it will take to reach over here. So the total height for now is how much? For that, we need to find the height for which it will go up. So the height will be how much? U square upon 2g. U is 20. So 20 square is 400 upon 2 times of g, which is 20. So this is going to go up by how much meter? So the height above the cliff is going to be 20 meter. Time it takes to go up is 2 seconds. Now the total height from the ground till the topmost point should be how much, my dear? That should be 60 plus this 20. So this height has to be how much? 80 meter. Now what next? I have to figure out how much time would it take to reach to the bottom position. कितना टाइम लेगा वहां से वापस आने में? How much time will it take to reach to the bottom position? ठीक है, कोई बड़ी बात नहीं है. We can do that. We know that h is equals to what? Ut. If I just assume that, maybe let's say keep it in this way, it's gonna make it easy for you. H equals to ut plus half at square. In this case, s will be the total height, a will be the gravitational acceleration. Now let me assume that upward direction is positive for me. I assume the upward direction is positive. Abhi dekho. So in this case, the body is coming from here to here. So guys, make sure that you do play around with the sign properly. Do not mess over there. Don't mess up over there, or else your answer will be wrong. So since the body is coming downward direction, this has to be how much? Negative 80. Please do not go wrong on this. Let me repeat this again, this point. Since the displacement of the object is towards down, and I've taken the downward as negative, that means this is going to be negative 80 meter. All clear? Initial velocity, of course, 0. So 0 plus 1 by 2. G is going to be acting downward. So that is going to be how much? Negative 10. Time, I have no idea. Let's say that is t square 0. So this is going to be how much? If you cancel the negative sign, 2 times 10, 5. 2 times 5 is 10. 5 times 16. 16 is going to be t square. So the value of t is going to be plus minus 4. Minus we will not consider. The time cannot be negative. So it will take 4 seconds to come down. So here we have the 4 seconds it will take to come down. Now the question was asking how much time will it take to travel from this point to the bottom. So that would be the total time. So the time that it took to go up was 2. The time it took to come down is 4. So the total time of flight should be 2 plus 4. That is 6 seconds. And that is your answer, my dear. Well, this is one way of doing the question. You guys can make a note of this one. You can make a note of this one. And the another way I'm going to do is, I'm going to use the equation. So let me just erase this up. इसको मैं थोड़ा साफ कर देता हूँ. Now we're going to do the same question with the second method. इसको हम लोग आराम से easily with the second method we can do. Okay, so this wire is always been a trouble. Anyways, अभी देखो. Now let us understand this. The second way of doing it. Method 2. So method 2. We know that the body's initial position is this much, final position is this much. So what is the net displacement? That is how much? Negative 60 meter. Keep that in mind. It's got net displacement because the body when reaches here, its net displacement is going to be negative 60 meter. We have the formula. That h equals ut, since the gravity always acts downward, so negative half gt square. As I told you, net displacement is negative 60. So can I just say negative 60 is equals to u. U was towards upward. Ensure that it is upward. So plus 20. Time I have no idea. Minus 1 upon 2. G is 10 t square. So that would give you what? Negative 60 equals to 20 times of 2 minus 5 t square. So this is taking me towards a quadratic equation. So I can have what? 5 t square negative 20t minus 60 is equals to 0. That implies if you take the 5 common, if the quadratic equation that should be t square minus 4 times of t, negative how much? 12, 0. I can actually factorize this now quite easily. So that should be how much if you solve it? T square minus 60 plus 2t negative 12 equals 0. So of course t you can take common, t minus 6, and you can take 2 common, we'll be having t minus 6 equals to 0. That means, okay, from the next time onward I will directly write this. No need to write each and every step. ठीक है, पहला question इस तरह का. So the value of t is going to be how much? 6, or the value of t is going to be minus 2 seconds. Of course, this cannot be the answer. So right away you can get to this answer. Simple. Energy, everyone? You got the point, all of you? So these are the two ways in which you can actually solve these kind of questions when the body is thrown from a cliff. Now we can have more variations, small variations hota hai. I'm going to discuss a couple of that. So in this case, they have given you the initial velocity, they have given the height, and they asked you to find the time. Now the second format, what they can ask you is, they would probably give you the time and they would ask you to find the height of the cliff. That could be the next type of question which can come across. चलो एक कर लेते हैं. Let us do one before I go to the complex questions. एक और question करते हैं. If you have not done it, pause the video and note it down. And make sure that whatever I'm going to do today, you try and solve those kind of questions, maybe from SC Verma, from your Aurora, whatever you have. And you can also give it a try. Probably, maybe Irodo we can do later. Once I do start with you people doing some questions. So that will just give you the motivation and of course the confidence. I'm going to show you the questions from your Irodo. देखते हैं, उसको भी हम लोग देख लेंगे, कोई दिक्कत नहीं है, मजा आएगा, ठीक है? It will be a fun. But make sure whatever you're doing, you do that in a proper sequence. Okay. चलो एक क्वेश्चन करते हैं. एक क्वेश्चन करते हैं कि भैया, let's say इधर ही लिख लेते हैं. A body is thrown from the cliff. This cliff का height is missing. The body is thrown from a cliff. The height of the cliff is not given to you, and it is thrown at, let's say, 10 meters per second. And it is said that it takes some 5 seconds to come back to the ground. It takes 5 seconds to come back to the bottom. So it went up, tick, 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 and it come back to the ground, and the total time it took was 5 seconds. You have to find the height. What is the height of the cliff? What is the height of the cliff? So everyone pause the video and try to do it as soon as possible. And then once you're done, unpause the video and then you can watch the solution. ठीक है ना? बढ़िया. चलो then, you can pause the video. Alright, I'm sure you guys must have done it. चलो करते हैं. Let's do this one. Okay, I know one thing. Just now we have seen that we can easily understand what is the displacement, which is how much? Minus h. Simple सी बात है ना? तो मैं second method से करूंगा. I'm going to do by the second method. And I want you guys also to try the same method. No need to go with that finding the time for this and that. उतना करने की जरूरत नहीं है. वो बच्चे लोग करते हैं. आपको जरूरत नहीं है. Net displacement is downward. So minus h. Initial velocity upward 10. Time is how much? 5. Minus 1 upon 2. G is 10. T square 5 square 25. खत्म कहानी. So minus h is going to be 50. Minus probably 5, 125, minus h is 75, h is 75. देखो कितना easy, how easy is this, right? So the height of the cliff is 75 meters. है ना जी? So this is the one of the easiest way I feel to find the height of any object if it is thrown from the cliff or कुछ भी vertical motion में this really works out. You just need to understand the displacement, whether it is upward or downward. What is the net displacement? नीचे है negative, ऊपर में है positive. Frame the equation and just get it done. है ना? अच्छा, देखो एक और question that I personally feel that you guys should be knowing. Before I get into that, थोड़ा सा और समझाना चाहता हूँ. I would like to discuss something with you people. देखो, let's suppose a body is thrown up, है ना? इसको मैं इधर draw कर लूँ. A body is thrown up with certain velocity. Let's suppose u. It will go up, ऊपर जाएगा जी, है ना? ऊपर गया और वापस आ गया. At the top position, velocity is 0. यहाँ पे 0 है, no doubt. The body would start coming down after this. So let's suppose in 1 second the body is here. This is the journey of 1 second. Then let me tell you one thing, my dear student. Before 1 second of reaching the top, the body should be at the same level. This is after the 1 second after the top, and this is 1 second before the top. So this journey is also covered up in 1 second while going upward. Level would be same. Provided there is no air friction, there is no drag, simple is that. Now let's suppose in the 2 seconds, the body comes down to this position in 2 seconds. Then 2 seconds before it was about to reach the top, the body should be here with, of course, with some velocity. Now, in addition to that, let's suppose it was having a velocity of u dash over here. Then at this point also the velocity should be u dash, but that should be just downward. हमने इस पे discuss किया था in the previous video. And here let's suppose the velocity was u double dash or something. Do not get confused with the derivative. You know, u dash is not a derivative. चलो मैं हटा देता हूँ, बाद में बोलोगे किसी ने बीच से देखा तो they will get confused with the derivative, है ना? So it will be having the same towards down, and we also know that it will hit the ground backward with the same speed, of course, and velocity would be in the opposite direction. इतनी बात तो clear है अपने को, ना? चलो, तो इसी पे क्वेश्चन करते हैं. Let us do one question. एक क्वेश्चन मैं लिख देता हूँ आप लोग के लिए. So due to lack of projector, ठीक है? तो here we have. Let's suppose question कि you know the body is sort of dropped. Body is dropped from the top. Body is dropped. So definitely in each second it will come down. It will come down with every seconds. Now, so you have to find body is dropped. Find the ratio. Find the ratio of, you know, you can say distance moved in 1 second, 2 second, and okay, and 3 second, or maybe second करते ना, second में कितना चला, third में कितना चला, like that. So maybe you can say, अब चलो 2 second कर लो, ऐसे ही कर लो, and third second. In third second. So how much displacement or how much height would it cover while coming down? So the ratio you have to find for the first second, second second, and the third second. It's pretty hard. ठीक है जी. All good? तो ट्राई करते हैं इसको, है ना? इसको थोड़ा ट्राई करते हैं. इसको हटा देते हैं. Let us move that. So basically, they're asking you the ratio of the height or the distance that it is covered in the first 3 seconds. Basically, you know, that's the bottom line. अच्छी बात है. So let's suppose the body is dropped. यहाँ से body drop किया गया, initial velocity is 0. So let's suppose in 1 second the body comes over here. Maybe certain value of height it is covered in 1 second. So this is the 1 second. Let's say दूसरे second में the body is here. At the end of second second the body is here, and at the end of third second, let's say the body is here. इतनी बातें clear है? Now we know that h is equals to what? Ut plus half gt square, g being negative, so I'm going to put a minus sign over here. So we'll be having, sorry, ut, this is going to be minus sign. u is 0 in all the cases, है ना? u 0 है. तो यहाँ पे distance कितना हो जाएगा जी? Over here, this length, that will be how much? Half gt square, t is 1 second, तो रहने दो t 1 square. This length, so this is this length, okay? Let's make it very clear. This is this length. Now, the length that it covers in 2 seconds. Let's suppose from here to here in the 2 second. That would be how much? Half g, t is how much? 2 whole square. And in 3 seconds, that is from here to here, total distance, you know, that's going to be how much? Half g, 3 square, no? So that is going to be like this. Clear है ना? तो भैया रेशियो कितना हो गया? बड़ा सिंपल हो गया ना जी. This ratio upon this ratio upon this ratio. So देख लो उसको कितना हो गया? That is g upon 2 is to your 4g upon 2, और ये कितना हो गया जी? 9g upon 2. That means ratio is 1 is to 4 is to 9. ऐसा कुछ है ना? In the same question, if I ask you the distance moved in first second, the second second, and the third second, that could also be one of the question, right? ऐसा हो सकता है, why not? So first second is going to be same. No worries about that. Now second second, only in this time interval, the distance should be how much? This minus this. So the distance moved, the height moved in this time interval, that is over here to here, that's going to be how much? This minus that. तो निकालो जी. The first is going to be g upon 2, कोई दिक्कत नहीं. Second will be how much? This minus that. And this is how much? 4 by 2, 2g square. So let's say 2g square minus g, 2g, my bad, 2g upon 2. Now distance moved in this part should be how much? From here to here minus this one. I believe you guys are okay with this. That should be how much? 9g upon 2 minus this length. That was how much? 2g. Or you can say 4g upon 2. दिखने में अच्छा लगता है. So here we have what? G upon 2 is to 3g upon 2 over and is to 5g upon 2. तो भैया रेशियो क्या हो गया? That implies ratio will be how much? 1:3:5. So this is when we have the distance or the ratio of the height traveled in first second is to second second is to third second, है ना? ऐसा कुछ. ये हो गया भैया कि 1 second में कितना है, 2 में कितना है, third में कितना है. But this is like in the first, in the second and in the third second. This is how we can actually counter this question. है ना जी? कोई दिक्कत? So अब आगे चलते हैं. Let us quickly cover a couple of more questions because the questions will be, I mean, like good questions are there. There are very good questions over there. I'm going to try and cover as much I can do. I'm also trying to sort of drop some PDF of the question and where you can get some practice paper. I'm sure you guys have a lot of materials along with you. But if you feel that you need some more good questions, let me know. You're in the comment box. I would definitely going to help you. Okay, it's just like, a lot of things are going around, so it takes a bit of time. So, but if you need some more practice question, do let me know in the comment box. I'm going to help you with that. And if you have not watched the previous video of the vertical motion, I'm going to drop the link probably in the I button, and you can watch it from there. Also, the link would be in the description. You can also go from there. Because I would advise you to watch the previous video of the vertical motion before you tackle with these questions. Well, that was the fundamental. The concept was delivered there. So if you know them, I mean, like dealing with these questions is going to be an easy task for you. So make sure to check the, the description box and the I button. You would get the link for the previous videos. Anyways, so we are done with these few questions. अब थोड़ा और करते हैं. एक और example, let us discuss. Okay, so this is the fourth example. Let's say a body is dropped from here, U0, and it's coming down. It come across a window, it's come across a window over here. So let's suppose there's a window, and let's say the height of the window is 4 meters. There's a window, and the height of the window is 4 meters. So when this object was crossing the upper part of the window, it had a velocity of, let's suppose, v1, and when it was crossing the lower part of the window, it had a velocity of v2. Of course, v2 is going to be more than v1, no doubt, because the moment you go down, your speed, your velocity would increase. Now my question to you is, find v2 minus v1. That is the question. So you can pause the video and try doing it. Once you're done, and pause the video, and then you can watch the solution that I'm going to discuss over here. ठीक है जी? Okay, so I believe you guys have done it. You have tried it. चलो इसको करते हैं. Let us do this one. Okay, so when it comes over here, यहाँ पे आता है, I have no idea how much is the velocity. कुछ height भी दे नहीं रखा है. Nothing is given. One thing is given, that this velocity change occurs after 4 meters. So one more thing, I think I should give you the time, because without that, let's suppose time लेता है जी 0.5 second. Okay, my bad. The time taken to cross this window is 0.5 second. It's 0.5 second. Now I think you should try. Okay, my bad. Now you can pause the video and try it, and then probably you can watch the explanation. Okay, anyways, take it. So it took 5 seconds, 0.5 seconds, sorry, to cover up this length at this point. So can I assume this is my initial position? Let's say the body is at here at t is equal to 0 and having velocity, initial velocity of v1. So it is a case which you can assume, you can correlate that a body is thrown down with certain velocity. It's not dropped, being thrown down. तो कोई मुश्किल नहीं है. We know what? H is equals to ut minus half gt square. The reason why it is negative, because z is downward, so negative. How much height has it moved? 4 meters towards down, so negative 4. Negative 4. Let me repeat this, it's negative 4. The reason, the body's initial position is top and the later position is bottom, Body is moving downward, and downward I always try and take the negative unless in certain specific situations. U is how much? Negative, downward. V1, how much time would takes? 0.5 seconds. है ना? बहुत कम लग रहा है क्या टाइम? रहने दो, क्या फर्क पड़ता है? Negative 1/2. G is 10. Time is how much? 0.5 seconds. Okay, let me just have the square. Okay, G. So, yeah. Now, so हम लोग कहाँ थे? This is what we are doing, you know. So this way, actually, I can find the value of V1, you know, ऐसे निकल जाएगा. Also, we can find the value of V2, you know. So we can do a lot of stuff. We can do that. But what is question asking from you? They're not asking you the value of V1 and V2 individually. Rather, they're asking you the value of the difference of V1 and V2. So is it a good way of going about it? I would say no. Then what is the easy way of doing it? And the right way of doing it? Do we know this? V square is equals to U square plus 2AS. We're trying to figure out some relations, right? Over here, isn't it? So that way we can find. Also, we know that V is equals to U plus AT. Okay. Now this looks quite an efficient way of doing it, right? Because that would give me the difference, V minus U. I know the value of A, I have been given the time. So it probably looked difficult in the beginning, maybe the lengthy in the beginning, but in reality this is easy. What is V2? What is V? V2. What is U? V1. Equals to A is how much? Minus 10. What is the time? 0.5 seconds, right? So that tells you V2 minus V1 is equals to how much? You can say, you can see what? This is going to be how much? Downward, na? Okay. So V2 is downward. V1 is also downward. So let's say minus idhar karenge ji. Here we'll have minus. My bad, you know. This is going to be minus V2 plus V1. Yeah. Well, definitely because V2 is downward and both V1 is downward. So here we'll have what? Minus 5. Now that means what? Take the minus common. So V2 minus V1 is equals to 5. Hanaji, all good? Now, you guys have an homework over here. You have to find V2 plus V1. Also, you can find V2 upon V1. These are the two homework for you. Once you're done, let me know the answer in the comment box if you have actually done it. If not, I'm going to discuss with you in the next session. So, if anyone could do this one, these two questions, let me know in the comment box. मैं भी देखना चाहता हूँ कितने लोग इसको कर पाते हो. All good? Fair enough. I'm not done yet with these vertical motion question. The time is a constraint. I wanted to make sure that video should not be that lengthy. So I'm gonna make one more video. Let me repeat. I'm gonna make one more video with the questions on the vertical motion. Am I clear with that? Yes. So be ready for one more, probably the short video on few more questions. The idea is very simple. Whatever we study, we must ensure that we do that to 100%. Because the reason why a lot of people could not solve the questions when it comes for any competitive exam, the reason is they do till, let's suppose, 50 to 60% difficulty level, and they get a feel, okay, I have done the entire topic. But the reason is, in those competitive exams, the question would come maybe from, let's suppose, 75 to 100% level of questions of difficulty. And that is the reason which you have not done. You only live till 70%, and some people do till 80%, and they're going to lose the marks if the questions comes in the gap bandwidth of 80 to 100% difficulty level, okay? So make sure that you do complete each and everything till 100%, or else there's no point. You understand my point, yeah? So we're gonna cover up some more questions. So just to get more variations, if the test taker tests you probably in any bandwidth, you should be able to do that. But yeah, okay. So till then, take care and do like and subscribe, and don't forget to share with your friends. Well, again, that's going to help them to learn something new. And I'm going to make this entire video lessons on the entire topics. That's what already I've told you. So yeah, with that, I'm going to see you in the next video lesson. Till then, take care and keep learning and keep studying. Bye everyone.